Hi, you guys. Now, this is the video that shows how to do the computational formulas for variance and standard deviation. Okay. So, it's a little slow today. Sorry. All right. So, I've got the same numbers from the problem, the sample test. Okay. If you skip the other video, the front page sort of looks like this, and it's showing that formula. So these same numbers are what I'm using, the 74, 79, like that. Okay. All right, so 74, 79, 82, 83, 81. Okay. So what I'm going to do in this is just show you the computational formula is the sum of the x's squared minus the sum of the x quantity squared divided by n, and then divided by n if it's a population. We'll divide by n minus 1, it's a sample. Okay. Notice that only the very bottom of the formula changes. And this is true when we're doing the formula, when we did the formula for definitional formula. Only the bottom changes. N minus 1 back into n if we're looking at a population versus a sample. Okay. So the top will be the same. All right, so in this, we want to do the sum of the x squareds like that. So we want to get that number in our calculator first. So we clear it out, and we'll just go 74 sigma plus, 79 sigma plus, 82 sigma plus, 83 sigma plus, 81 sigma plus. All right, I've got all 5 numbers back in here, okay? The mean, just to verify that you've got everything right if you want to check it, 79.8. Okay, I'm good, because that's what we got on the mean on the other one. All right, so now here's what we do. The first one says the sum of the x's squared. This button on your calculator is the closed parentheses right here. You look above, it says sum of x squared. Okay, so I'm going to hit second, close parentheses, and I get 31891. Okay, so I put 31891. The next thing is I need the sum of the x's quantity squared. So the sum of the x button is second, open parentheses, and it's 399. Okay. So now I have those values. Okay. And I can put the 31891, sum of the x squareds, minus 399 squared divided by 5. And let's, for this sake, we'll start with the population divided by 5. Okay. So if you go 399 while we're here, don't clear anything out, go x squared, you get 159201. Okay, so 159201 divided by 5, divided by 5. So if you did the math there, pick this up here, did the math, all right. So 159201 divided by 5 gives us 31840.2. We'll divide that by 5. So 31891 minus 31840.2 gives us 50.8, and we're dividing by 5. Okay. Remember from the last one that the top part of that formula was also 50.8. The sum of squares is what we call this, is 50.8. Okay, and so you get the 50.8. We're going to divide by 5. So our variance in this case is 10.16. And okay, when we did it before for the variance, before, and the last one, we also got the 10.16. You take the square root of that. Okay. The standard deviation is the square root of the variance. Okay, so for a population, that's the symbol we use. The square root of 10.16 equals 3.18747, so 3.19. Okay. Now, for a sample, the top of the formula is exactly the same. The only difference is you're going to divide by 4, n minus 1 instead of 5. So 31891 minus 399 squared divided by 5. Do that all out just like we did a minute ago. And you get back to this point where it says 50.80 divided by 4. So now our variance is 12.7. This is the variance for a sample. That's exactly what we got last time when we did the definitional formula. We take the square root of 12.7, 3.5637, so 3.56. When you went through the video for the last problem, we got the same exact thing. Oh, sorry about that. We got the same exact thing when we did it using this formula. For a sample, we got 3.56. Okay. So 2 formulas. One's a lot more unwieldy, but it actually tells you what you're looking for, which is the average difference from the mean. Oops. So that's the average difference from the mean. Okay. The other formula, the computational formula, gets you to the exact same place with a lot less keystrokes, but it's good to know both. All right. And for the exam, you'll need to know both.